Let's review the regression results here in the notes. So the first thing I have is the top table. I have the regression statistics. I have the adjusted R squared. Remember, R squared versus adjusted R squared, and this is again for the multivariate regression. The R squared is the portion of variation of returns described by variation of the factors. It measures the model's fit. The larger the value of R squared, the smaller the errors and the closer the dots are to the line. Well, adding more variables to the right-hand side can't make the R squared smaller. It can only make it bigger. Even if it's just completely random and unrelated, then it can't make it any smaller. Any sort of spurious or random relationship between this new variable I've added and what it is I'm trying to measure will make the R squared bigger. And so the adjusted R squared accounts for this. The adjusted R squared only gets larger if the improvement in fit from adding the extra variables is greater than what we would expect if it were just chance. And so again, the R squared will always get bigger even if I add just lottery numbers, anything completely random. It's going to describe some portion of the return. But the adjusted R squared accounts for this. It only gets larger if it's the case that the improvement is more than we would expect if it were chance. So here's the rule. I use R squared for a single variable regression, for a single factor model, and I use the adjusted R squared for a multi-variable or multi-factor model. And so in this case, I would conclude that because I have multiple factors, that 77.14% of the variation in the portfolio's return is described by variation of these three factors. The next thing is the coefficient block. And so here again, I have alpha. It's negative, but it's not significant. And I know it's not significant because this is not less than 0.05. In fact, it's 85%. And so I would conclude that there's an 85% chance of observing this if it really is zero. So I would conclude that there is no risk-adjusted excess return, either positive or negative. The beta for the market is positive and significant. It's 1.04, and I can conclude with greater than 99% confidence that this is not zero, so therefore it is statistically significantly different from zero, and so therefore the market does affect this portfolio. The next is the small stock premium, small minus big, and I can see that this is positive and also significant, and so therefore this small stock premium is a factor, is a priced factor, and I would conclude that this portfolio behaves like a small stock portfolio, therefore it is likely a small stock portfolio. And HML, the high minus low, which is the value stock premium, is negative and significant, and so therefore I would conclude that this is likely moving in the opposite direction of the value stock portfolio or value stock premium. When growth stocks do better, it does better. When value stocks do worse, it does. When value stocks do better, it does worse because this is negative, and so therefore I would conclude that this is a growth stock portfolio. And we saw that when we looked at this on Excel. Let's look at the forward-looking expected return. And so now I'm looking at what happened afterwards, but what's looking at beforehand, and we just did this in Excel again. We can use this to calculate the required equity return or some sort of cost of equity capital. And so here I have the expected risk premium. If this were a stock, it doesn't quite make sense for a mutual fund. So for a second or two, let's pretend this is a stock if we're thinking about this in terms of the cost of equity capital. But I can also think about this as the required return the expected return for this portfolio. So I have my three factor betas. I know they're significant, so I'm using them. I have the expected value for my three factors. And again, these are just averages of the last 60 months. I could do something different if I wanted, but I'll just use the expected values. And so I take the product of these. So 1.04 times 0.85, 0.5 times negative 0.19, 0.3 times and that should be, negative 0.81, and I get 1.03%. This is a monthly expected return. I would then annualize the expected return, and then I would add to this annualized expected return the risk-free, and so big R becomes little r, and I get that the expected annualized return for this portfolio is 12.52%. And I can compare this to the CAPM expected return. Remember, the CAPM beta was 1.11. Here, the beta of the Beta of the market is the only factor because I'm looking at the CAPM. I get 1.11 times that same expected market. I get 0.94. I annualize it. I add the 0.13 and I get 11.43%. And so my single factor model, I come up with an expectation of 11.43, but my multi-factor model, mainly what's driving this is the fact that I have a positive expected return for growth stocks relative to value, or a negative expected return for value relative to growth. Since I have this negative beta, this is adding to the return, and so my multi-factor expected return exceeds just my CAPM expected return.